Good morning to all of you. स्क्रीन विजिबल है आप लोगों को? Okay. Okay, let's just start. Today's lecture is on examples of push down automata. From the past 2 to 3 lectures हम लोगों ने ये देखा है कि अगर आपके पास एक पुश डाउन ऑटोमेटा आ जाए of any type, deterministic or non-deterministic one, तो उस पुश डाउन ऑटोमेटा को देखते हुए क्या आप उसका लैंग्वेज या पैटर्न या जो कॉमन ग्रामर है उसे प्रिडिक्ट कर सकते हैं या नहीं? या फिर हमने ये देखा कि अगर मेरे पास एक ऑटोमेटा हो तो उसका अगर हमें कंप्लीट फ्लो बताना है यूजिंग द टेप एंड यूजिंग द स्टैक, कैन वी डू दैट? और द थर्ड थिंग इज कि अगर मेरे पास एक पुश डाउन ऑटोमेटा है तो एंड अ स्ट्रिंग इज गिवन एंड आई हैव टू ट्रेवर्स दैट स्ट्रिंग one symbol at a time, and then I have to decide that whether that string is accepted or rejected. ये तीनों चीजें हम टर्न बाय टर्न अलग अलग तरीके से कर चुके हैं. Now the lecture says that this is the examples of push down automata, that you will be given a language. आपके पास एक लैंग्वेज होगा, बेस्ड ऑन दैट लैंग्वेज आपको एक पैटर्न डेवलप करना है कि किस तरीके से यूजिंग वन स्टैक यू कैन इवेलुएट दैट. ओके, और उसी पैटर्न को फाइंड करने के बाद हम लोग एक पुश डाउन ऑटोमेटा बनाएंगे एंड वी हैव टू राइट वेरियस ट्रांजिशन फ्लोज ऑन टू इट, जैसे हम लोग DFAs में करते थे कि हम लोगों ने पूरा का पूरा ऑटोमेटा बना लिया. आफ्टर डिफाइनिंग द ऑटोमेटा वी हैव टू गिव इट्स ऑल 7 टपल्स अलॉन्ग विद द ट्रांजिशन फंक्शंस और ट्रांजिशन टेबल एनी. सो ये हमारा मेन फ्लो रहेगा अभी. सो एग्जाम्पल नंबर 1 says, the very basic example, the most common and the most important example in push down automata or context free languages, which says that to design a PDA for accepting a languages, that the number of A's should be equal to the number of B's, plus the A's should come before, all A's should come before A or before B, and then after those A's the equal number of B's should come. So A raised to the power n and B raised to the power n. So what am I meaning by this? That A raised to the power n is given and then B raised to the power n. If I am just saying that the number of A's should be equal to number of B's, there can be two cases. One is that you are facing consecutive A's and then followed by consecutive equal number of B's. The another case comes when here also we are having equal number of A's and B, but they are not in a particular order as defined by this language. This language says that all equal number of A's should come before and then they should be followed by those equal number of B's. So this type of strings are not acceptable here. It will be rejected. Only this type of strings with any number n greater than 1 will be accepted. Okay, I think this is very basic thing. ये आप लोगों को clear है. Now what logic will I follow? अब I know that I am having a stack. Firstly, this is of type context free language. Why? क्योंकि हमें क्या चाहिए कि आपके पास a raised to the power n जो है, this n could be any, it could be infinitely any, और आपके पास ऐसा मशीन होना चाहिए जो हर बार इस नंबर ऑफ एज जो है a raised to the power n, दिस n जो है इसे मेमोराइज करे, याद करे, और उसके बाद आपको इक्वलेंट नंबर ऑफ b's जो है वो भी कैलकुलेट करने में हेल्प करे, जिसके बाद आप बता सकते हो कि ओनली दिस टाइप ऑफ स्ट्रिंग इज एक्सेप्टेड, वेयर एज एनी स्ट्रिंग ऑफ दिस टाइप ऑफ एनी अदर टाइप दिस विल बी रिजेक्टेड. So इसलिए this is not possible to draw a deterministic or non-deterministic finite automata for this, because DFAs or NDFAs are not providing us external memory space along with the machine or finite control to memorize the things. But we have an option here to go for PDAs, push down automatas. The speciality of PDA is that it, along with a DFA or NFA, it is having a memory space which is particularly stack. So this stack will help you to keep a count of this n, and then it will give you equivalent number of b's after n also. So we have followed a simple logic that this, in this language, n number of a's should be followed by n number of b's. This is the clear statement. Hence what we will do, we will read a single a, and with each read operation we will push that a, push a single a. Okay, this is wrong. Push a single a onto the stack. Then after it, whenever a b comes, my job is to pop that a. Whenever that b comes, I have to pop that a and change the top of the stack to top -1. It will get updated, and at the end what I will check, that with every pop operation my stack is now having lesser elements than the previous one. And at the end, when the string will get completed, when the tape is at the end, I have to check that whether my stack is empty or not. And if it is empty or having the starting stack symbol in it, which is z, then I will say that this string is acceptable. So the clear logic says that if I am having this finite control, okay, and this is any type of string which is of the which is of the form 0 raised to the power n, 1 raised to the power n. Similarly, it could be a raised to the power n and b raised to the power n. I have 3 consecutive zeros followed by 3 consecutive ones. Finite control is there, and this is my stack. Initially my stack is holding the stack symbol, the initial stack symbol, which is defined in your 7 tuple machine as one of the elements. Initial stack symbol, which could be $, z or z naught, it could be any in different books. So what I'm saying, that I am having this string, this is my tape, this is my finite control, and this is stack. As soon as I will be reading one element from here, for each zero I am pushing any element x according to the problem in my stack. And then with next zero, next x will be pushed. With next zero, next x will be pushed. Whenever I came to know about a 1, whenever a 1 is detected, a first 1 will be detected. At that time I have to perform pop operation for whatever is present there in the stack. X is popped, 1 has been read. Next one comes, then another x. Then next one, another x has been read. So at the end, when I am having such situation that my tape is also finished and also the stack is there with the initial stack symbol z not only. So at that situation, my string will, I would say my state will change to the final state, which is f, and now this will act as the final state with double circle. So this will bring the string to an end. If any such string comes where I am having, at the end I am having any symbol here in my stack, but the tape has been finished, so in such cases we will say that string has been rejected. Okay, yes, आई होप आप लोगों को ये सारा फ्लो जो है वो क्लियर है। a रेज टू द पावर n एंड b रेज टू द पावर n जो है वहां पर कौन सा लॉजिक फॉलो हो रहा है, एंड हाउ द टेप एंड स्टैक थिंग आर को रिलेटेड विद ईच अदर। इज इट क्लियर एवरीवन? यस, किसी को कोई इशू है तो बताइए। जो मैंने अभी आपको करवाया है स्टैक ऑपरेशंस एंड द सिंपल लॉजिक, इज इट क्लियर? ओके, नाउ अब हम लोगों ने एक पैटर्न फाइंड कर लिया। उस पैटर्न के अकॉर्डिंग नॉर्मल स्ट्रिंग्स जो हैं वो भी हमने ऑपरेट करके देख ली यूजिंग दिस एग्जांपल। अब बारी आती है टू ड्रॉ दैट पुश डाउन ऑटोमेटा।
Hello,
जब हम
madam.
हेलो, यस।
Hello. Yeah, madam. Like, since we are using stack, can't we also use a queue? Since it's also a data structure which can also have strings, and it can also use FIFO, first in, first out. Why
नो
do you have to always pop it?
No, but stack follows the property of LIFO, last in first out.
Can
Yes,
it?
yes, yes.
Sorry. Since you are popping it from the stack, can't you use a queue so that when the first goes in, the first comes out?
Okay. You are saying that we have a number of data structures. Why we are using only stack over here, right?
Yes.
Yes. So for that, we say that generally the problems that we are facing, yes, of course, even a queue can be used, but what we have observed in context-free languages, that one is these total number of A's and total number of B's should be equivalent. So in this case, whether I would be, suppose I am taking a Q over here. So Q says that this is the front side, suppose, and this is my rear side. Okay. So as soon as I have started to enter three A's, one way is that I will be performing the delete operation or pop out operation for this queue, basically the dq operation that we say. The dq operation will perform the similar type of function that once one A will be deleted and this will came to the end, then this A will be dequeued and this A will come near the front end. Again this will be deleted or dequeued and then our queue is empty. So the final type of string that I am getting or that I am comparing is of the form A, because all three A's are eventually A's. There is nothing different. Similarly, we know if we use a stack, it will be uh, popped out in reverse order, but eventually they are A's, so it doesn't matter for it. But if I am having another type of problem, which is generally the palindrome problem. Okay. In this type of problem, what do we face? It says that for any type of string, if you are reading it from the left to right side or you are reading it from right to left side, it will give you the same string, uh, in irrespective of the pattern that which you are following, whether left to right or right to left. So this is also of context free nature. It is not possible to generate any deterministic finite automata for this, so I have to go for push down automata. So let's try that if I am using a queue to evaluate it, and the another option is that I am using a stack to do this. So the problem comes here that you know that there is a property of stack that it can be used to reverse the string. Why? Because everything that you are going to push into the stack A, suppose I am pushing A, then B, then C. Whenever you are going to perform the pop operation, it will pop out as first C will pop out, then a B will pop out, and then a will pop out. So my initial string was ABC. After popped out operation, it will give me the reverse of the string. But in queues, the same string that I am performing the NQ operation, that I am inserting, it will give me the same string after performing the DQ operation. So for this type of strings which are of nature palindrome, or a mixture of string with one string as original and another one is of reverse type, so for these type of strings, they again come in the form of push down automata, context free languages. So I cannot use a queue here, I have to strictly use a stack to perform this operation. Now in this case, what I will do, I will push a 1 in any way. I will find out the middle of this string. So middle of string is 2 here, so I have to push two elements in my stack, 1 and then 0. Then a middle has been detected. After that middle, I have to start popping out whatever element is present there. So I will pop out a 0, and 1 0 has been read here. Then again I will pop the 1, and this 1 will be read. So in this case, even palindrome type of strings can be verified or can be accepted by push down automata. That's why we are particularly using stack over here. Okay, I think it is
Yes,
clear now.
ma'am.
Okay, good. So now my main focus is that we have came to that situation to draw the push down automata. So any automata consists of some states represented by circles, and then some transition flows are there. Okay, and with those transition flows, I have to write certain alphabets or logics to define the flow basically. So what I will do, I have taken, suppose I state has been taken, which is the initial state, and a a simple arrow which is coming from no other state has been detecting that this is the starting state. We know this. So we will do what we have to do in every push down automata, that in the starting state you have to initialize the stack to only contain z. Now this symbol could be z, it could be z naught, it could be the dollar symbol based on the different nomenclatures used by different authors or in different books. Okay, it could be any, actually it is any special symbol which is saying that what is already there, there should be already one element present in your stack. Okay, only one element should be present in your stack at the starting of push down automata, so we are taking it as z. Now my first thing came that I have my stack settled with z. All right, I am at a state I, a state finite control is defined. That is also good. Now the next thing comes that I have to read the tape. So you can compare this thing with this, that at the center I am having a finite control, which is my state I in the diagram. Z naught, which is their stack has been initialized to z, and this is my tape. From this tape I have to read one symbol at a time. So suppose my here my language says a raised to the power n and b raised to the power n. That means only a and b symbols can be read. So initialization done, state has been defined, and my first thing says that push all a's into the stack. Push all a's and a self loop. That means you have to traverse first a and then push it, then again a detected, pushed it, again a. For any n number of a's you can perform that push operation. Then next, whenever you detect the first b, because we know this type of string, after all the a's has been finished, only then all b's should come. This should not be the criteria that I am having two a's first, then three b's, and then one A should come. This is not the criteria. This is specified that first all A's should come, and then all B's of the equal length or equal occurrences should come. So whenever you detect first B, then pop one A corresponding to that B and change the state. Change the state to suppose B. B is my new state now. Now for the number of A's that has been pushed, or for the number of B's that you are detecting in the tape, in the string, you have to perform pop operation again. So pop all A's for every B. The number of B's that you are detecting in your string, you have to keep on performing the pop operation for A. Okay, once the tape is end, once you have reached the end of the tape, then you have to perform the pop operation on the Z symbol. So this will act as a I would say verification now, that if you observe that the tape is empty, plus there is at the top there is Z element present, only then you can move to final state. What if the situation come, the tape is empty but pop Z cannot be performed? Why? Because in my stack maybe there is any A element or any B element present, so I cannot pop Z. My machine will halt at B, and since B is not final state, so it will reject the string automatically. Okay, so this is the basic logic that following which we have to draw the push down automata. Now the thing that we know, that in push down automata I have to write my transition in this form, that a state q1 is there, another state, that this q1 state has been changed to q2 after following this type of operation. So always you have to write your transition flow in this form: a, a variable or a symbol comma another symbol, then followed by any other symbol. So basically it says that these two are my input symbols and this third is my output symbol. How? That this A is the input tape symbol that I have to read, that I am at q1 stage. From the string a symbol A has been detected. Okay, then I have to check the stack. In the stack, perform pop operation on this symbol and then followed by push operation that you have to perform after performing pop operation. So these two symbols are related to stack, and in particular order, that first is for pop and another one is for push, and the first one is for the input tape symbol for the string that we are reading. Now I have to convert this thing in transition flow manner. So what I will do, so I have just done one thing, that it says that you have to push all A's whenever they are detected. So what I have done, I say that whenever you detect whenever you detect A symbol in your tape, there could be two criterias. Either you are having a Z symbol in your stack initially. Obviously, it could be the thing based on this one, that initially I am reading a, suppose a is here, I am reading a and initially Z naught is there, one case. Another one, that first element is pushed, now again a or 0 is being read, but at the top I am having any other element other than Z naught. So I have to write both cases here. Okay, then for A input symbol, top of the stack is A or top of the stack is Z, and we know that second symbol says that you have to pop this element. Okay, once I will pop A, the next one says that you have to push the elements. I know that I have popped A here from here, but I need that A. I need each and every A to be pushed into the stack so that I can pop them afterwards whenever a B is detected. So that is why what I will do, I will pop two A's here. One A is for what I have detected, and one A is for this pop operation that is performed. So technically, two A's are involved here. So that is why I have to push two A's. Similarly, A symbol is detected. That means A has to be pushed, but top of the stack is Z, and I have performed pop Z operation here. So that is why I have to write A Z. Why? Because I have popped this Z also. I have to take it back, and also for each read symbol, read operation for this A, I have to push A also. And now a question came that can I write, I have written there A, Z and AZ in this form. Can I write it as this? Yes, anyone, if anyone can answer. Can I write my transition flow in this form also? ZA. I have already explained this in the previous lecture. Acha. Now suppose if I would write my stack is there. Okay. Just tell me one thing. Whenever you are going to push a string, just concentrate on this thing that a string is there. I have to push a complete string. By which order will it be pushed? How we have to read the string to perform the push operation, from left to right or right to left. That suppose there can be two cases. One is that first I will push A, then Z. Another could be first I will push Z, then A. These two type of stacks can occur, but ideally which one is correct? Which one is correct? One way is that I am reading it from left to right. Left to right says push A, then push Z. Right to left says first push Z and then push A. So which one is correct? Yes, Rohit. Rohit is correct. Right to left is correct. Okay, right to left. Always, whenever you are talking in terms of string, a string is written. So you have to know that right to left is the pattern to push the strings. Okay, so this one is correct. Right to left says first Z will be pushed, then A will be pushed. So for this also, I have written ZA here, but the rule says that right to left. You have to go to right to left. So if I go right to left, what is observed that first push A, then push Z. Now know this thing. What is Z symbolizing here? Z says that I am the starting stack symbol. Now, since it is the start stack symbol, how can A come prior to this Z? This should be at the starting, this should be at the lower end of the stack. So that is why this is the correct thing. This Z should always occur at the lower end. To get it at the lower end, it is necessary that my string should be read from right to left, so it should be written as A Z. this method is totally wrong. I have to write it in this way. Okay, so you have to very careful while writing this, that it should be written in this way, that your z should always be pushed first. To push it first, it should be at the rightmost end. Okay, clear everyone? हमारा जो z है वो स्टार्टिंग स्टैक सिंबल है, वो हमेशा लोअर एंड पे ही होना चाहिए। लोअर एंड पे लेके आने का मतलब है राइट मोस्ट साइड पे रखो, तो हमेशा राइट मोस्ट साइड पे आपका z रहेगा, तो वो लोअर एंड पे ही आएगा। सो दिस इज रॉन्ग, दिस वे इज करेक्ट। सो दैट इज वाई वी हैव रिटन ए जेड हेयर। ओके, बिकॉज हम लोगों ने यहाँ पर एक ए के पॉप कर दिया था, प्लस एक नया ए डिटेक्ट हुआ है, दैट इज वाई ए। Similarly, one Z has been popped out and a new A has been detected. So I have to take this Z back also because I have popped it, and also I have to push another A also. So AZ is written because the pushing occurs from right side and Z should always be at the bottom. So this is for the those two cases, that whenever A is detected and in stack I am already having a, and another cases I am having a Z there. So I have to perform these operations. Now next thing says, change the state when first B is detected and pop 1A. So change the state means I have simply provided an arrow, that is fine. And it says whenever a B is detected, that means input symbol is B, and my stack should have, now I know that I have to perform pop operation. So my stack should have a, and this A has to be popped out. And what I need to push? I have to push a null symbol. I mean, that means an empty symbol, an empty string should be pushed in. Just perform the pop operation. Simple. Now you are at the B stage now. We know that here I have to pop all A's for each B. Whenever a B is detected, pop A, push nothing. B, A, and null symbol. So when you are with end with this B's, you have read all your B's here. Now with the end of the input tape, that means the input tape symbol that you are reading is null now. Null is written, and at the top of the stack there should be a Z. Why? Because in the beginning we have written this Z here, and my problem says that for every A that is pushed, it should be, when it is popped out, the equal number of B's should be there. So technically I should observe a Z there, and I have to pop that Z. My stack is empty and I have reached the final state. Okay, so this will be my automata that I have to design, and these are the tuples that are defined, that the set of states, the alphabet set is there. Toss symbol says the alphabets of stack are there. Initial state, the initial stack character or stack symbol. Then I am having this C, my set of final states, and then transition table. We know transition table में आप क्या आएगा? Your state, then your new state, the symbol that you are reading, what is the top of the stack, and what update you are going to perform in that stack. This thing in detail we have already done, so I will not repeat it again. Yes, everyone tell me, is it clear to all of you how to draw any PDA? Is it clear? Is this clear to everyone? किसी को कोई डाउट है तो बताइए. Please write in the comment section, is it clear or not? Yes, good. Now moving on to another similar example. Now my example is that I am having n number of A's and the number of B's are double the number of A's. A raised to the power n and B raised to the power 2n. This is my problem. And since I know that there is a relationship between the occurrences of A and occurrences of B, since there is a relationship, a memory space is required. It will not be possible to create a finite automata, deterministic or non-deterministic finite automata. So this clearly means this is not a regular language. This is context-free language. And for every context-free language, there exists a push-down automata. So we define this logic that it is saying that n number of A's should be followed by twice the number of B's. Okay, if there are 3 A's, then it should be followed by 2 into 3, 6 B's. 2 A's are there, then 2 into 2, 4 B's should be there. This is the logic. So, how I would adjust my stack so that I can solve this problem? So, I would say that whenever I read a single A, I will push 2 A's in my stack. I will directly convert my single A from the tape, and I will push 2 A's in my stack for every single A in stack in my tape. Okay, and while performing the pop operation for every single B, I will pop out single A. So clearly it will give me double number of B's for there in my language. How this actually works, suppose this is my string. We know 3 A's are there and 6 B's are present here. How the machine will work, for every single A, one A has been read, and for that A, 2 A's are pushed in the stack. Similarly, for another A, another 2 A's are pushed in. Okay, for another A, sorry, this is the fourth one, and this another A is read and another 2 A's are pushed into the stack. Now it says whenever you detect a B, okay, you have to pop out single A. Another B is read and A is popped out. Another A is popped out. Then another A, and then again another A is popped out. Okay, and at the end I am having only there is end of the tape and the stack is at Z0. So I will move it to the final state F, and the string is accepted. Now we came to the push down automata. So push down automata says similarly push 2 A's in stack for 1 A detected in the tape, and then change the state when B is detected and pop 1 A, and the next one is again pop all A's. Okay, whenever the tape is empty, pop Z also. So this is same, only here the thing is that for every single A, push A 2 times. Okay, now we know the flow is same, the number of states are same, but the only difference occurs over here. How am I going to write all of these transition symbols? Okay, so can anyone tell me, अब आप लोग क्या मुझे बता सकते हो? The thing is, 1A in tape, push two A's. This is the simple criteria. Suppose I am at I stage, okay, and my transition says that I to, okay, we are taking another example. Q naught stage is there. From Q naught, I have to go to Q1, okay. Q1 is there. If I am talking about stack, I am giving you a situation right now. At my stack, I am having only Z, okay. Q naught to Q1 you have to go. At stack you are having Z, okay. And for every A you have to perform a push operation for two A's. How you are going to write this operation? You have to write it like this: A, B, C. That this should be your reading symbol. This should be the pop function. This C should be your push operation. How will you write this? Yes, you can write your answers. Like in previous one, I will give you a hint. In previous one, I have written A is detected. Okay. And at the top of the stack, I am having Z. Okay. So technically what I have to do, I have to push A. But because I have popped out a Z already, so what I will do, I will first push a Z and then push A. This was the thing for A to A pushing. Now the situation has been changed. This A should be pushed as double A according to the situation. So how will you write this function according to this situation? Just write it, or at least try to write it. अब तो मैंने बहुत बता दिया है. This is very easy now. Yes, write your answer. Yes, everyone, are you clear with the problem, that what am I asking? देखिए, हम मैंने आपको बोला कि पहले वाले सिचुएशन में हमने क्या किया था कि आपके पास ए सिंबल है, टेप से रीड किया आपने. स्टैक की बात आती है तो स्टैक के टॉप में आपके पास जेड है और आपको इस जेड को पॉप आउट किया. ठीक है, स्टैक खाली हो गया. लेकिन पुश क्या करना है, क्योंकि हमने ये जेड पॉप आउट कर दिया तो हमने लिखा था पहले आप जेड को पुश कीजिए एंड देन क्योंकि हमने ए सिंबल को रीड किया है, ए जो है वो भी पुश इन होगा. ठीक है, सो दिस मीन्स कि जब भी आपके पास एक ए डिटेक्ट होता है तो आपको एक ही ए पुश करना है. दिस वॉज द थिंग. अब हमारी प्रॉब्लम चेंज हो गई है. हम लोगों ने लिखा कि जब भी आपके पास एक ए आएगा तब आपको उसे 2 टाइम्स ए के साथ पुश करना है. So how we will write this thing in this form? Pooja, I'm not understanding it. This is little bit confusing. Write it in this form using semicolons so that it will be more clear. This semicolon says that this is the tape symbol, pop operation, push operation. Okay, wait. What if we write it as whenever A is detected and top of the stack is Z, that means pop Z. Okay, since I have popped Z, which is required, so I will first push Z, and now the thing comes that for every A, how many number of A's are required? 2 times A. Simple. This should be the case. Okay, suppose this is there is a problem, okay, where I am saying every a okay, for every a in tape, push bb in stack. Suppose this is not concerned with our problem, we are just taking an example. Suppose this is the situation, then how will you write it? This, for every A in tape, push BB in stack. And similarly, top of the stack is the Z. Z is there. So what I will write, whenever A is detected and I have popped out Z, what I will do, since I have popped out this Z unnecessarily, I need it. So I will push it back and write. We know that every time I have to write the string as right to left, so Z is written. Now I have to write BB. Yes, Rohit, correct. I hope now you get it. Now just let me just change this problem to something like this. For every A, push BA in stack. How will we will write it? Yes, yes, Anisa, correct. Okay, so this that is why now just check this thing. Just compare it with your answers, that what we want to change. I have done, that there could be two scenarios. How, uh, let's go to this example, that at the very beginning I have read one A. Okay, I have read this, and in my stack the top symbol is Z naught. So one situation can come when you read A and the top of the stack is Z. Another situation, when you have already performed read operation first time, then you will observe that you are reading A, and in your stack top of the stack is also A, with A and A Z naught. These two type of situations are occurring. So this is the reason that we have written two forms here. One is for A, another one is for AZ, and the thing remains same. Since A is popped out, I have written this A, and for every A I have to push 2 times A. So that is why triple A is written. Then A and Z is there. For every Z, I have written Z again, and for every A, 2 times A is required. So that is why AAZ is written. Now, when what will happen when we move to the next case? We know that already there are some A's. There cannot be this scenario that there is a Z symbol in this case, because A comes prior to B. So that is why we are not taking that Z thing here. Okay, we are directly saying whenever a B comes, the top of the stack should have a, and you have to pop that A and push nothing. Null symbol is there. Similarly, change the state. Whenever you are at B, you have to perform that operation repeatedly for every B that you are observing. For every B, pop A and push nothing. Whenever you observe that those B's have ended, you have not no enough B's, end of the string has been observed, empty string is observed, and top of the stack is Z. Top is at Z, push that Z, um, pop that Z, and change the state to C, and this C is my final state. If any of your string will traverse through this and reach the C state, final state, that means it is of type that it should have the a number of occurrences of B's twice the number of occurrences of A, and it should be accepted according to this automata. Okay, so similarly, this will be its tuples. Okay, clear everyone? The main thing comes with that how you are going to write this thing, the transition function. You have to just work on this. The rest thing is just the similar that we have already done in deterministic automatas, finite automatas. Okay, good. So there are some examples, like I am having what it says, that you have to design a push down automata which accept the language that a string is there W. Okay, then a symbol C comes, then the reverse of string W is there. So what type of string it will be? You can do this by yourself. This is very easy. It is saying W, then C symbol, and then WR. Suppose, let's say my W is ABA or ABB, suppose ABB. Okay, then technically my complete string will become ABBC, and then reverse of W, BBA. So this type of strings, any strings of this type where at the center there is a C, to the left of the C there could be any string, and to the right of it there should be the reverse of the left of the string, BAB again. So this type of strings, how we are going to design a push down automata so that we can accept these type of strings. Okay, similar three states will be used here. Three states will be used, and according to that you have to perform push operation and pop operation. What we will do, we will say that whenever you observe a, okay, push it. Whenever you observe a B, also push it. You can perform push operation for both. But whenever after this A, B, a C is detected, change the state from I to B. Change it to B, and do not pop anything, do not push anything. And when you are at the B state, for every B, pop it. For every A, pop it. And at the end, if you see that you are at Z0 situation, then go to the final state, and this says that the string is accepted. Okay, so you guys will try this, and if you face any problem, then you can get it checked by me. Okay, you can discuss that with me. ये easy है, ये हो जाएगा. Similarly, if you are not having any middle symbol, but the problem is same, how this will be done? यहाँ पर एक empty transition होगा. Okay, this will be of non deterministic type. इसके जैसा एक प्रॉब्लम हम लोग ऑलरेडी कर चुके हैं क्लास में. ओके, देन वी हैव सम मोर एग्जांपल्स आल्सो. आप इस पर भी काम कीजिएगा. यू हैव टू जस्ट डिफाइन अ लॉजिक. एक लॉजिक डिफाइन करना है, उसके बाद जो है वो हो जाएगा सारा. ठीक है. यस, आर वी क्लियर विद पुश डाउन ऑटोमेटा एग्जांपल्स? इज इट क्लियर टू
Yes,
एवरीवन?
ma'am.
ओके जी, गुड. अगर किसी को डाउट है तो बता दीजिए, अदरवाइज वी विल मूव टू अटेंडेंस. आप लोग प्रैक्टिस कीजिएगा जो आपको नए प्रॉब्लम्स दिए हुए हैं, और देन वी विल डिस्कस इट. ओके, वी विल हैव अ रिवीजन क्लास. वहां पर जिससे जो प्रॉब्लम सॉल्व नहीं हुआ, दे कैन आस्क इन द रिवीजन. ओके, okay, so these are the students who are present. Clinton, Ajay, Amritpal, 41, 42, Anisa, Ankit, Anmoldeep, Arshdeep, Bablu, Barinder, Chandni, Dimple, Divyanshu, Garima, Gurmanpreet, Gursimran, Harjab, Himanshu, Ishdeep, Jaspreet, Kritika, Kuldeep, Kunal, Roshila, Lavleen, Madhav, Mansi, Morris, Navi, Neelam, Neha, पूजा, राधिका, राहुल, रियाका, रोहित, सईदा, सौरभ, शमशेर, सिमरन, सिमरनजीत, सुधीर, तनवीर, दयारानी, विकास 48, 49, विशाल 52, IT students Anand, Ankit, Jaswinder, Rajveer, Ruchi, then CSC Basant, Jotin, Pooja, Kurba, and IT lead Bhajandeep and Kamal. इनके बिना अगर कोई प्रेजेंट है तो मार्क योर अटेंडेंस प्लीज.
मैम चंद्रगुप्त मौर्य.
ओके, डन. एनीवन एल्स? जिनका अटेंडेंस हो गया दे कैन लीव एंड बी रेगुलर इन योर क्लासेस गाइस.
Ma'am, Diksha 660.
ओके दीक्षा, डन. एनीवन एल्स? All right, then I suppose everyone's attendance is done. Thank you everyone.